Hello, my name is Rudraksha and I am giving the demonstration of 6.1. So this is the basic authentication code of 6.1 pre. In this, it is a simple authentication scheme built in to the HTTP protocol. In this, we have two classes: basic authentication options and basic authentication handler. Basic authentication options inherits from authentication scheme options. This class provides configuration options for our authentication scheme. In our case, it's left empty. Now on to the basic authentication handler. This class inherits from authentication handler basic authentication options and implements the logic for handling authentication. In the constructor, we inject dependencies such as options, logger, encoder, and clock. These dependencies are essential for handling authentication requests. Next, Next, that is handle authenticates a sync method where the actual authentication logic resides. We start by checking if the request contains an authorization header. If not, we fail the authentication. If the header exists, we extract the encoded credentials from it. We then decode the credentials from base 64 and split them into username and password. With the username obtained, we fetch user data from our data source. In this case, it's user data access class. We then use ASP.NET Core built-in password hasher to verify the provided password against the hashed password stored in the database. If the password verification succeeds, we create claims for the authentication users. Here we add the user's name and a role such as admin. With the claims, we create a claims identity, a claim principal, and finally an authentication ticket signifying successful authentication. We return authentication result.success with the authentication ticket if authentication is successful. Otherwise, we return authentication.result fail. So for the next code, I am going to explain mapcontroller.cs. In this, the API controller and root API slash method attribute. They mark the class as an API controller and specify the root prefix for all endpoints in the controller. Our first action get map retrieves all maps from the data source. Get square maps returns maps that are square shaped. The map get map by ID fetches a map by its unique identifier. Add map adds a new map to the data source. Update map updates modifies an existing map without providing the ID. Lastly, with providing the ID, sorry. Lastly, delete map removes a map from the data source. Now notice authorize policy is equal to admin only here. Attribute on each action. This enforces the admin-only policy, ensuring that only authorized users can access the endpoints. For the next file, that is robot controller command.cs. Just like before, notice API controller and root. They mark this class as an API controller and specify the root prefix for all endpoints in the controller. For the get all robot commands, our first action retrieves all robot commands from the data source. Get move commands only returns only the commands related to movement and same for everything. Data explained in map controller.cs. Also, there is also policy is equal to admin only, ensuring that only authorized users can access these endpoints. For the next file, that is userscontroller.cs. Our first section, that get all users, retrieve all users from the data source, get admin users, fetches only admin users from the database, get user by ID, retrieves a specific user by their unique identifier, add user, user model adds a new user to the data source, hashing their password before storage, update user, int ID, user model and modifies an existing user's property, including updating their hash password, delete user int, removes a user from the data source, update user credentials, update user credential, updates a user credential including hashing their password before storage. For the next file, that is persistence in map data access.cs, we start with a constant connection string that holds the connection details for our PostgreSQL database. GetMap retrieves all map from the database, populating a list of map objects. GetSquareMaps fetches maps that have equal rows and columns representing square maps. GetMap by ID. AddMap insert a new map into the database with the specified column, rows, name, created date and modified date. Next is update map. Updates an existing map in the database with the provided ID, modifying its column, rows, name, description, and the modified date. Delete map removes a map from the database based on its ID. For the next code, that is robot command data access.cs. The robot command data access class provides methods to interact with the database for robot command related operation. Similarly, connection string that holds the connection details for a PostgreSQL database. Get robot command fetches all robot commands from the database, populating a list of robot command objects. Get robot command by ID retrieves a specific robot command by its unique ID. And here we can see that all everything is same defined as in map.access.cs. Moving on to user data.access.cs. In this, as I explained earlier, get all users fetches all users from the database, populating a list of user model objects. Get user by ID specifies user by their unique identifier from the database. Add user. Add user inserts a new user into the database with the provided details. Update user modifies an existing user in the database with the provided updated details. And delete user removes a user from the database based on their ID. Get admin users retrieves all users with the admin role from the database. And update user credential updates an user email and password hash in the database. Moving on to login model.cs file. Here, here login model class has three properties. That is ID, email, password. ID represents the user's ID, email represents the user's email address, password represents the user's password. We also have a constructor in the login model class which initialize the object with the provided values for ID, email, and password. This is an exploration of login model class in ASP.NET Core. It serves as a simple yet crucial component for handling user login credentials within our application. For the next file, that is map.cs. Map class defines the structure of maps in our application. It holds information such as the map ID, dimension, name, description, and creation modification dates. Map class has the following properties: ID, column, rows, name, description, created data, modified data. ID represents the unique identifier of the map. Column represents the number of columns in the map grid. Rows represent the number of rows in the map grid. Name represents the name of the map. Description represents the description. Created date represents the date and time when the map was created. Modified date represents the date and time when the map was modified. The map class constructor initializes a map object with the provided values of for ID, column, rows, name, creation date, modification date, and the optional description. Mainly examination of the map class in ASP.NET Core. It serves as a fundamental component for managing maps within our application. For the next file, that is program.cs file, we start by setting up the necessary service for controller, adding API Explorer service, and then configuring authentication and authorization. First, we set up services required for controller and API Explorer services using the add controller, add and add endpoints API Explorer method. We configure authentication service by adding the add authentication method. We specify the authentication scheme as basic authentication and link it to a custom authentication handler. After configuration authentication, we set up authorization policies. Here we define two policies, admin only and user only. Finally, we build the application and enable HTTPS redirection authentication and authorization using the use HTTPS redirection, use authentication, and use authorization methods. And there you have it. We have successfully configured authentication and authorization in our ASP.NET Core application. Moving on to robot file. The robot command class defines the structure of commands that our application sends to robot. It includes information such as the command ID, name, description, whether it's move command, and creation modification dates. The robot command has the following properties: ID, name, description, is move command, created date, and modified date. The robot command class constructor initializes a robot command object with the provided values for ID, name, whether it's a move command, creation date, modification date, and optional description. That concludes our examination of the robot command class in the ASP.NET Core. It's essential for managing commands for controlling robots within our application. Thank you for watching. This is the whole demonstration of 6.1p task.